On today's topic, we'll be talking about modeling and life cycle management on BW4HANA. We'll have two presenters, myself, Chris Avelli, and also joining me we'll have Joe Darlick. Just as before we go through the presentation, I understand initially this webinar was presented as a data acquisition, modeling, and lifecycle management. What we notice is that a lot of material to go over in just 1 hour. So we also decided it would be better to actually move data acquisition to October the 10th, when Marcus Paulis will be driving the third webinar of this particular series. So data acquisition and reporting analytics will be presented by Marcus Paulis on October the 10th, and today's session will be data modeling and lifecycle management. So, of course, before we go over the contents and talk to you guys on the modeling and data lifecycle topics, of course, we go through some introductions. Comerit, the company that we work with, it's a global management consulting firm. We were the first partners of SAP to actually be certified on delivering SAP BW powered by HANA solutions. So it's a great achievement, and this is because we have been working with SAP HANA implementations and migrations for a long period now. I joined Comerit back in 2012, so we're just myself. I have already been working with HANA platform for the last 5 years. All this experience has, of course, translated into a lot of knowledge, a lot of experience that we'd like to share, and we, as a group, we have some books published together with SAP Press. Some of the books are being presented on this slide, as you can see. The latest one being the BW4HANA, an introduction, and that is actually the content that we will try to compact as much as we can in just this an hour to go through the topics of this particular introduction. So this is Comerit. We will be at the SAP TechEd this year. So next week we'll all be there in Vegas. So if you guys are joining SAP TechEd next week, yeah, please come and see us at booth number 807. And also we're going to have a signing session of the SAP BW4HANA book scheduled for Wednesday on 11:30 a.m. So I'll be there. Jasper also will be there. So it will be fun if you guys can come and chat with us and meet us. That will be very, very nice. So before this is Comerit. So before we go through the presentation, let me introduce myself. My name is Chris Avelli. I have been working with SAP technology since 1998. Actually, I started as an SAP employee back in the days when BW was still the 1.2, 1.0 version. So I have been working with BW since its inception, and that has been a very interesting, I would say, experience, because it's not just the evolution of a particular application or a tool, it's actually the evolution of a concept from what we understood as being data warehouse back in the 90s to 80s and 90s to what we now envision as what is a true data warehouse solution. So that has changed, and BW4HANA is the answer for some of those changes. We're going to see through the presentation. So I have pretty much like 17 years of experience plus on SAP specifically. On IT world, I have over 20 years managed primarily BI initiatives for companies around the world. So that includes, of course, US, Canada, Europe, Australia, Brazil. And so it has been different companies, mining, banking, manufacturing, logistics. And talking about logistics, that's an interesting point as well. I have a logistic background, so I'm also certified on the ECC side, and we're seeing some very interesting things happening today on the ECC side with the S4 HANA. So that's again, it's a game changer with the introduction of the HANA platform. But I'm not alone in this presentation. There is another person on this presentation that I respect very much, and I think he's one of the top experts in the market in terms of SAP HANA platform and technology. And I'm going to now ask Joe to introduce himself to the group here. Joe? Okay, so it seems that maybe Joe has a little bit of key issues at the moment. So,
hello, can you hear me?
Now I can hear you. All right, Joe, go ahead.
Hi, guys. My name is Joe Darlak. Sorry about that silence a few moments ago. I also have been working with BW since 1998, back with the 0.2a version, and so I have a long history with implementing BI via using BW and native HANA with many large-scale global rollouts for my clients, and hopefully I'll have something interesting to share with you guys today. Chris, I'll turn it back over to you.
Thank you, Joe. So yeah, that was a little bit of suspense before, like your introduction. So that was interesting, but good that everything is sorted out now. So guys, let's dive into the contents. Again, there is a lot of material, and that's why we didn't go through the data acquisition today as well. I have about 20 minutes to go over the modeling concepts. Of course, this is an introduction, so we won't be going very, very deep because there is not enough time, but there's going to be very interesting change of paradigm on modeling that I would like you guys to start thinking when going over, modeling on BW for HANA. So let's switch to the...
Hello, everyone. It sounds like Chris is now gone on mute. Hopefully he'll be able to get his audio fixed here in a moment. In the meantime, I'll just go over the agenda very quickly. Chris is going to cover a logical EDW architecture, and then he's going to cover modeling in BW4 HANA. He'll talk about the modeling perspective and different object types, field-based modeling, and then cross-modeling, also known as mixed-use scenarios between native HANA and BW. Then he'll transition back over to me, and I will cover data lifecycle management, including the data temperature concept and the data storage options, and then kind of a brief overview of the implementation process. Once we reach a conclusion there, we'll open up the line for questions. All right. Hopefully Chris is back now. Chris, are you there? All right. Please hold by while we try and resolve this technical difficulty. All right, attendees, our technical guy is checking. I think we've got Chris sorted out now. Thanks for your...
Yes. Can you hear me?
Yes, we can.
Joe, okay, beautiful. Yeah, so one thing that we just learned, okay, two presenters, do not mute your phone, okay? Maybe I'm going to mute you and you mute me, but that's fine. So let's get ahead on the modeling side, if you guys are hearing me well. And Joe, please let me know if for some reason my voice is cut off. All right, guys, so I think what I was talking about on data warehousing back in the days, in the 80s and the 90s, and the concept of data warehousing today, it has changed. In 2012, Gartner actually mentioned the first time the name logical data warehouse, the LDW. And that was the evolution to what we see as the data warehouse back in the 80s. Back in the 80s and the 90s, what we're trying to do was to actually protect the transactional system against analytical requests. The infrastructure was not powerful enough to hold the data, process the transactions, and at the same time allow you to start doing extremely intensive analytical and processing in the same box. So the idea there was how to actually preserve the performance of the transactional system by isolating this transactional system from your analytical requests. And the concept then was to try to move the data out of the transactional system into a separate server where it would be storing the data for analysis. And that was the data warehouse concept that everybody's familiar with, and what today we call the traditional repositories or the traditional data warehousing. Well, at that time, we were in a different world, like in terms of we didn't have even internet. I remember people would actually send a fax with a sales request, and then we would actually input that sales transaction in the system, and they start internal process to actually supply that particular request with a product that was being bought by the client. Now, in today's world, it's completely different. If you are only isolated to the data that you generate yourself in your company, you're losing a huge chunk of data that surrounds your company, and you may actually be losing a lot of insights. What Gardner was trying to say is that the logical data warehouse, the LDW, is this new way of architecturing your data management. You no longer have only your company to provide you data for analysis. You have to consider other source systems. You have to consider other external sources, like you probably heard about IoT, the Internet of Things, the streaming, some of your vendors now, the transactions are coming through directly through interfaces, and already starts a process in your system. So you may need some event management, process mining. So it's no longer just the data that you're generating in your transactional system that it's relevant for your analysis. It's outside your enterprise. It's surrounding the content that it's surrounding your particular enterprise. So that is the logical EDW architecture, is a way that you have to supply for different analytics, from different front ends, you have to supply different data, different sources. No longer just the data persisted on your data warehouse. You may actually integrate with big data. You may actually just virtualize data from a particular external source. SAP knew about this concept. SAP knew that the concept of the data warehouse, as in the 80s, was no longer just sufficient for the new reality. Therefore, there needed to have an application to be able to address the logical EDW requests. And that was when SAP decided to come up, of course, with first the platform, the HANA platform as your base, and then create a new application. The platform as a base is to give you the processing power, and then comes the application. The processing power is your HANA platform, and the BW for HANA is nothing else than a HANA native application. So to address the logical EDW architecture needs of today's world, SAP then introduced first the platform, followed by a completely new application. So when you look into the BW for HANA, it's no longer your BW application. It's a completely new product. This product has been completely developed to support the LDW needs, the logical data warehouse needs. And for those, typical needs are openness. So you have to make sure to be able to access data that's not just generated in your company. You also have to have openness to provide that information, that data, to different destinations. It could be a planning tool, it could be a SQL-based front end, it could be your typical analysis for Office. And one of the interesting things is using the HANA in-memory platform, and therefore an increasing processing power, you may no longer need to prepare the data as much in terms of different layers of persistency in order to have the result in a way that a report can run with acceptable performance. You can now start thinking on persisting the data once and then logically combine with external sources and create logical models that can be consumed, but without having to move the data across or massage the data in order to just prepare it for performance purpose. So that's the concept of BW for HANA. BW for HANA, SAP came in order to address the logical data warehouse needs. First thing in terms of modeling when accessing this new application, if you're familiar with the former SAP BW application, the one that we mentioned, the any database, the former BW solution that's called BW NetWeaver, you'll be going to something called the Transaction Administrator Bench Transaction RSA1, and be actually modeling directly in that particular SAP GUI interface. On BW for HANA, this is no longer the case. Okay, BW for HANA, SAP is developing based on the HANA platform. One of the key points here is BW for HANA, of course, only runs on HANA. So the data modeling section of activities on the BW for HANA are done on a new interface called SAP HANA Studio. So your modeling activities are on Eclipse-based front end. And this particular Eclipse-based front end is comprised of what's called perspectives. The perspectives is nothing else than a group of functionalities associated to a particular activity. So if I'm, for example, database administrator, I would access a particular perspective that would show me all the functionality that I need to administer the HANA database. If I want to actually perform some development, if I want to create some tables directly on the HANA database, I'll be accessing a perspective called Developer's Perspective, where I'm going to have all the features and functionality that would help me and assist me in creating tables and views and some of procedures inside the HANA database. If I am a BW modeler, and I'd like to create some BW objects, BW for HANA objects on the HANA platform, I'll be accessing the BW modeling perspective. So this is the first key thing is, when we talk about modeling BW for HANA, we're talking about the BW modeling perspective on HANA Studio. It's where you're going to create the different objects. The idea here, again, is that this is the LDW solution for from SAP. When modeling objects on the BW modeling area, there is some new object types that you have to work with. So again, I like to do this parallel between the traditional NetWeaver system, BW for HANA. So people that have background on NetWeaver BW will quickly adjust or transition to the new BW for HANA object types. So I'm accessing HANA Studio, I'm getting to the modeling perspective, and then I have some options in there. The first thing that you're going to notice is that there are info areas. So if you are from the NetWeaver BW, there is the same concept of subfolders and folders like the info areas, where you can organize and put together your different object types. However, we don't have info cubes or info sets or mode providers. What we have now are basically 4 object types. A lot of content in the internet talks about simplification. Oh, now it's much easier because you have a reduced number of object types. I like actually to see in another way. I see we have 4 object types because LDW, the Logical Data Warehouse solution, only requires basically 3 flavors, right? Or you need to seize the data into the HANA database, or you can virtualize the data, access an external data. And if you have these 2 contents, one persisted in the database and one that's virtualized in the database, then you need a semantic layer where you can harmonize these 2 sources, a logical layer, a reporting layer. So I don't need anything else besides those 3 major components on the logical data warehouse. Because I'm running on HANA platform, because I have my performance there, I can logically combine that data. I don't have to move the data through multiple layers. So the reduced number of object types, it goes again together with the LDW concept, and also because those objects are now offer you all the features that were before on different object types in the BW solution, the original NetWeaver. Of course, the BW solution, NetWeaver, has almost 20 years now of development work. And every time you think about a new feature, oh, I would like now a union instead of a join, the BW NetWeaver will create a new object type because there was a lot of development done on the former, let's say, mode provider. So you create an info set in order to avoid impacting the original system, the original object types that have been already in use for maybe 10 years. Now, BW for HANA is a completely new application. SAP does not need to consider, let's say, older developments. So one of the things is that it can combine all those features that are on different object types into just one. Mode providers, info sets, composite providers, virtual providers. Okay, so each of them, one can do a join, one can do a union. Well, why not have just one element called composite provider, and depending on the settings, you can then define if you want to join or a union. So this is what we call the flexible ways of configuring those elements. So they are supporting scenarios that were before supported by different object types on the NetWeaver applications. There are 2 major areas. One is the virtualization, and the one is the persistence, as I spoke before. For persistence, to store data into the HANA database, you pretty much have 2 object types. Info objects, of course, they keep the same concept as we had on NetWeaver BW, meaning they are for master data. The advanced DSOs or advanced data store objects are your main persistent object in BW for HANA. They can act as a DSO, as a typical NetWeaver DSO. They can also act as an InfoCube. They can act as a snapshot solution. They can act as a consolidation layer, depending on, again, the configurations you set. An OpenODS view is your virtualization tool, let's say. It's an element that can be used to virtualize data from external sources to the BW application, and then you could consume that, combine that virtualized data with some persistent data on a particular composite provider. So again, the composite provider, if you think about the mode provider info set, that's pretty much your semantic layer, your logical layer that combine those the 2 sources, and then is one that you can report on. So the key points here is that you have 4 object types, basically virtualization and persistency, and these are the elements you'll be modeling in the BW for HANA. What's interesting about the BW for HANA that differs from the NetWeaver is the possibility of agile data warehousing. So it's another concept that we have to make sure that we mention this. These elements that I just spoke about, the object types like advanced DSOs, OpenODS views, you don't need to have info objects to model those elements. You actually can create generic fields directly in the BW for HANA. You just give the type, the length, the name, and you create this particular advanced DSO with fields, no association to the master data. And this can go actually up to the query level. So I could have queries running on my BW for HANA solution without the need of info objects. And that's the beauty, because if you are from the NetWeaver background as I am, just to prototype a few data flows, sometimes I would need to create about 70, 75 info objects first, and then create a DSO, and then create the cubes, and then create the queries. I don't need to create those info objects anymore if I just wanted to do a quick prototyping or bring some external data that can remain without association to the master data. So that's the field-based modeling. And of course, all these BW object types can be easily converted into HANA native elements. I could take a particular advanced DSO that I created with info objects and expose this content to the HANA database through a HANA view. So now those tables become a logical HANA view that can easily be consumed with SQL-based front-end tools. So I can easily expose the BW content to other front-end tools by simply automatically converting those models into HANA native views. We're going to be talking about this into some of the other slides. Just to show you the three concepts that I would like to make sure that we speak on this session here: modeling flexibility, field-based modeling, and openness. So the first one, the modeling flexibility. Here I try to get a screenshot of the advanced DSO. So when you are in the BW modeling perspective and you are creating an advanced DSO, you have the following modeling properties here on the left side. I'm trying to actually use the pen and show you guys here. So you have the option of, say, I would like to activate data, like a DSO, when you move data from new to active table, and I would like to write a change log. So you have a change log table to actually track what has been changed on the active table, right? So this would be a typical DSO. So this advanced DSO would be acting as your DSO on a NetWeaver BW application. If you'd like, for example, to have this advanced DSO acting like InfoCube, you would instead be selecting the all characteristics are key. This would actually make this advanced DSO to no longer allow overriding, so it would be always addition. So any new data that comes into this advanced DSO, it's like an InfoCube, would be an addition, would be appending to this particular table. Snapshot support, if you'd like a snapshotting solution. Anyway, so the idea here is that the combination of those modeling properties here will drive the behavior of that particular advanced DSO. You don't need to memorize the combinations. Okay, I would like this guy to act like a standard DSO. So what I do, well, you can use what's called the model templates. So SAP provides you model templates in a way that you could just say, I like this to act like a standard data or a store object. By clicking here, those modeling combination of modeling properties would be set up automatically. So those are the modeling properties, and these are the modeling templates. Again, flexibility offered to you on those elements. You don't need all those object types anymore for NetWeaver. You just need 4, and depending on the features and the modeling features you set up, they will act like the different scenarios you may need. So first concept, modeling flexibility. Second concept, field modeling. You no longer need info objects. If you don't want to use them, or if that particular data flow does not require the master data association to the master data, what you could do then is just, when you're creating the advanced DSOs here, you could actually create the fields, give the length, the type, name, so generic fields, and bring the data, persist the data if there's an advanced DSO, virtualize the data if this is an open ODS. And the interesting thing is that up to the query, you still could use the generic fields. So I could then create a query, directly against this particular field-based advanced DSO. And BW4HANA would accept and provide you the results of the query the way that it actually assumes a prefix 2F against those generic fields, and the query engine works without any issues. So you can choose to have association or not to the info objects. If after the design you'd like that particular generic field to be associated, let's say, to customer master data on the modeling portion of the advanced DSO, you could say this particular generic field is associated to the master data. So if the keys are the same coming from the external source with the master data, customer master data, you have then, you will reach the generic field with all the attributes of that master data. So flexibility, field modeling, and the most interesting, in my perspective, okay, guys, the most interesting way of changing the way of thinking on modeling is to remember BW4HANA, okay, only runs on SAP HANA, right? What is the interesting portion on this one is that if you're running on SAP HANA, it means that you have another modeling options. You could model directly on the HANA database. So the HANA Studio has the BW modeling perspective, and also
Chris,
the.
Can you hear me?
Yes, I can.
We've got some people chatting that they cannot hear. I can hear you just fine.
Yeah, me too. They say one can hear, one can hear. Okay, I can see the people typing now.
Okay, so
Yep.
let's go ahead and proceed. It seems like multiple people can hear. Okay, thanks.
Okay, cool. Thank you. So I think this is the most interesting concept because there's a lot of debate about this. BW4HANA runs on the HANA platform. I can use the BW modeling perspective to create, object types, advanced DSOs, but I could also go to the HANA modeling perspective, right? And start creating tables and create HANA views. So what we call it the native modeling. So now you have two modeling areas, and they interact to each other in a way that, for example, I could just go back to an advanced DSO and just flag and say, create an external SAP HANA view. So what it does, if I have an advanced DSO on the modeling perspective and I flag create the HANA view, associated HANA view is created based on the advanced DSO model. What it means that now I'm exposing all the content of this particular BW object type as a HANA view, and this can be easily consumed with a SQL.
Hey, Chris, I'm sorry to interrupt you again.
Yes.
There seems to be a problem. They can hear me, but they can't hear you.
Can you hear me? Can you hear me, Joe?
I can hear you just fine.
Yeah.
But it seems that we've got a couple of people in the chat who cannot hear you. Support has asked them to re-enter the room.
Okay, so yeah, a lot of people is now replying that can hear both of us.
Yep. Okay. Good. Sorry for that interruption.
No problem, Joe. Thank you. No problem. Thank you. So, guys, I think this is interesting because a lot of people ask, well, then what should I do? When SAP introduced this, a lot of people start saying, oh, so HANA replaces BW, so it's the end of BW, and that discussion is still there. Things that we need to consider is the fact that you have two modeling areas now. I can easily use the enterprise information management to bring external data directly to a HANA table, and this HANA table is not part of the BW application until I create an open ODS view that can expose its data to the BW application. The same way, I could take a BW object type and expose to the HANA modeling area using the HANA views. So this is the cross-modeling options. People sometimes think of, okay, so what should I do and what is the right path? There is no right path. In my view, it depends on your current situation. Cross-modeling offers what we call endless opportunities now. One way of trying to combine, if should I go and start creating my LDW application close to more HANA native centered, or should it be more BW for HANA centered? Should I keep building elements on the BW for HANA, or should I start moving to the HANA native? Well, that's a question that one thing that can help you is, the first is, where is your data footprint points to? If you have a large SAP-centric data footprint, if the great majority of your data relevant for analysis, it comes from SAP sources, 80%, and maybe you reach that with some external data that you're pulling from a data lake, or you're pulling from an external source, and you're reaching your SAP information, you are an SAP-centric enterprise. Remember, SAP is delivering business content with BW for HANA that is tightly coupled with SAP sources. Therefore, there is dedicated SAP extractors that will follow any changes made to the S4 tables, for example. Those extractors will be enhanced the same way. Therefore, your business content will be aligned to your majority of the SAP footprint. So why not model on the BW for HANA? Because your large footprint is primarily SAP. Therefore, don't reinvent the wheel. Now, in a few cases, you could have a different scenario where, well, only finance department uses SAP. Everything else is non-SAP. My warehouse is all event management from other or sources from other applications. They are not SAP. Therefore, my footprint is about 20% SAP. 80% is not SAP. Then you could say, well, I will actually be potentially pulled over to the native modeling. I'm going to have a little bit of a BW for HANA footprint, because that's the finance data that flows from my source system, but I'm going to expose that information to the HANA view, where I can integrate with my remaining 80% of data that's non-SAP. So that's an interesting discussion. This goes into data strategy. Comerit helps a lot on this as well. There's a lot of interesting examples to use. But again, this is just an introduction. And to give you the four major concepts that I'd like to share with you. First of all, BW for HANA is a new product designed by SAP to address the LDW, logical data warehouse needs. You have pretty much flexibility modeling. You have openness, so you can easily bring data from different sources and also export the data, expose the data to different front ends. And the third and foremost is that you have endless options for modeling. Then it goes from BW for HANA modeling into the HANA native modeling. This is where we, I think, the modeling part of the session ends. And I apologize with a little bit of the technical difficulties we had with the sound. I know we went a little bit over with Joe, so I'm going to quickly, hand over to you. And guys, we have a Q&A at the end of the session. Thank you, guys.
Okay, thanks, thanks, Chris. All right, I'm going to move directly here into data lifecycle management. Some of you guys may recognize the picture on the right side of this. This is the information lifecycle management diagram that we've seen before. Probably the most important part of implementing data lifecycle management is defining what your data lifecycle strategy is going to be and what your data aging strategy is going to be, what data you're going to retain in your BW for HANA system, what data you may aggregate, what data you may move out into a lower cost storage, and what data you may even archive or delete, right? So working through that strategy definition is probably more complex. Sometimes you have to work with legal and audit holds on data, and that can determine what you are able to move out of your system or where you're able to move it and so forth. But finalizing that strategy is kind of the first step to implementing a data lifecycle management in your system. BW for HANA has several capabilities. Dynamic tiering is still supported for PSAs. There's some recent there's some evidence that ADSOs, advanced DSOs, may be supported for dynamic tiering in the future. Although as of the writing of our book, this progress had been stopped, and instead SAP had developed a concept called extension nodes as a new option for storing warm data. It's simpler than dynamic tiering, with many of the same benefits. We'll talk about that in the next slide. In addition, there's nearline storage using either IQ or Hadoop as a target, and then of course there's always traditional archiving. So let's move on to the next slide here. The data temperature concept is essentially a way to conceptualize where you may store the data that you access less and less frequently as it ages, right? So the data that you're going to query and report on very frequently is hot, and this data should be stored in HANA in memory, and this data must retain all read-write capabilities to it. I'm going to skip to cold. Cold data is data that you very rarely access, right? It's either very sporadic or very restricted. This data doesn't change, it's static, there's no updates to it. This is data that you don't need in HANA. You don't need to pay a large license fee to keep this data available at a second's notice, right? So this is typically the data that you want to move to a cold storage, which is going to save you dollars. Bottom line, it's a much cheaper storage alternative, but you're going to pay for that cheaper storage in the performance of accessing that data. In the middle, we have the warm storage, or the warm data. This is data that is accessed less frequently than hot, but you still need to be able to update data to it. You still need to be able to write some changes to it, and you still want performance when you query it, but it's not cold, so you're not going to completely write it off yet to your cold storage. You want to keep it nearby just in case it's needed. So typically your warm store is going to be stored on disk. So in HANA, this could be data that is ejected from memory, either via early unload concept, as SAP used to call the non-active data concept, right? So you could just eject this from memory, or you can put it on an extension node, which has a relaxed data to memory sizing, or you could put this data in dynamic tiering, which is all disk, but it's more and more tightly integrated, especially now with HANA 2.0 SPO2. It's more and more integrated with native HANA, or with SAP HANA. Cold storage would be either a standalone IQ instance or Hadoop, using NLS to access, to write and retrieve data via your BW system. All right. So let's talk a little bit about extension nodes. What are they? Really, an extension node is just another HANA scale-out node. The only exception to it is you can define placement groups for the extension nodes, and then assign your tables and partitions of your existing tables to those placement groups, and define that placement group as warm data, and that warm data will exist solely on your extension nodes, and your hot data will exist solely on your other scale out nodes. But from just a pure HANA perspective, there's really not a difference between a HANA extension node and a standard node. You still have to have a homogeneous landscape, which means if you've got 1 terabyte nodes, you still need to have your extension nodes need to be 1 terabyte. If you've got 2 terabyte nodes, your extension nodes need to be 2 terabytes. If you've got the memory limits capped on your nodes, you need to have the same cap on your extension nodes. But the difference is SAP supports a relaxed sizing or relaxed data to memory ratio on those extension nodes. So for example, you can have 2 to 4 times the data on your extension node that you might have on a standard node. So if you have a standard node of 2 terabytes, right, SAP supports 1 terabyte of data, roughly 1 terabyte of data on that 2 terabyte node. And on an extension node, SAP will support 2 to 4 terabytes of data on that node. So there's still only 2 terabytes of memory available in the extension node. And if you have 4 terabytes of data on disk, on the disk volumes linked to that node, there's no way that you can have all that data in memory at one time, right? So it's warm, it's not in memory, it's on disk, but it's close at hand. It can be called into memory if you need it. So you can kind of think of the extension node as more of a cache, right? So you want to try and optimize your hit rate in the cache. You're probably going to have a higher percentage usage of the memory on that node, maybe 80%, maybe even 90%. Every use case may be a little bit different, but you may have as much data on that extension node as you can possibly fit, and still have some operational memory for running reports. But you want to optimize your hit rate. So when queries do come for data that's in warm, you don't have to swap, but worst case scenario, it swaps. It drops something out of memory and pulls something into memory, right? So the great thing about extension nodes is your tables are the same, right? You don't have to do anything from a design perspective, right? It's a column store table in HANA. It can be partitioned, and some of those older partitions can be moved to the extension node, right? And so this makes it kind of very simple. It's really just more about partition management and distribution, which is purely operational, but it doesn't really affect your design too much if extension nodes are all that you're working with. When we talk about cold storage with using NLS, you've got 2 options, as I mentioned. You've got IQ and you've got Hadoop, right? Now, IQ has always been a target for NLS, and both IQ and NLS for IQ are proven technologies. IQ's been around for a long time, and it is a columnar architecture, just like HANA is. It just doesn't the always in memory component. It is a different engine than HANA, but with the latest improvements that the IQ engine is now sending back data in the format that's readable by HANA, so it's even faster than it was before. It uses an ODBC driver to write data to IQ and read it back from IQ via Smart Data Access. And overall, IQ performs, I would say, probably in order 2 to 5 times slower than what you might get out of your hot data directly in HANA, right? So it is a performant solution for warm to cool or cold data. Please ignore my typo there on my 4th bullet. Data stored in IQ, not Hadoop. It can range from warm to cool to cold. So you could use standalone IQ or NLS with IQ, even for some warmer data sets, if you did not want to go the route of extension nodes. Let's move on to cold storage with NLS for Hadoop. NLS leverages recent innovations in native HANA connectivity to Hadoop to provide this capability. You'll use the Spark SQL adapter, although there is also a Hive ODBC adapter, but NLS requires the Spark SQL adapter for reading and writing data. The data is read back again through Smart Data Access, but Hadoop as a data store for cold data, it should really be reserved for colder or even frozen data sets. Depending on your use case, it's going to perform less optimally than IQ and certainly extension nodes. So just keep that in mind, that it's not it's a use case specific scenario, and if performance and large data volumes need to be transferred back as part of your reporting on this infrequently accessed data, just be sure to do your homework and testing to ensure that this is the right solution for your use case. Right. How do you implement your data lifecycle strategy? Well, first you deploy your architecture, your warm and or your cold storage solution, whether it be dynamic tiering, extension nodes, IQ, or Hadoop. There's a couple steps here. First, you do need to create a remote source in HANA for your SDA connectivity. You need to define an NLS connection in the implementation guide of BW for HANA to use that remote source, and also define an RFC destination in SM59. There's also some security setup and so forth. But once you've got the connectivity set up, then you can identify which objects or tables or partitions you want to move to warm storage, an extension nodes or cold storage, and NLS. For warm storage, you just repartition those objects as necessary and define your placement groups, assign your objects and partitions to those groups, and then redistribute objects and partitions to the extension node. With NLS, or for cold storage, use the standard data archiving processes for each object with defined retention periods, and you can schedule that to execute on a periodic basis. Right? Just got a couple of slides here that show what it may look like to define a remote source for NLS. Here is where you define your remote source in HANA Studio. This is maybe what it might, when you create that remote source, you essentially set your credentials and connection properties to that remote source, and then within the implementation guide in BW, you would define your nearline connection here for NLS. Also, I thought this might be interesting. I'm not sure how familiar you guys are with repartitioning your info objects, but you can use report RSDU repart UI to execute repartitioning after you've loaded data into your cubes and DSOs. All right. Now we've got about 3 minutes left. I know it's not a whole lot of time, but let's go ahead and open the floor for questions. I'm going to set this. Well, you know what? I think it's probably best if we just answer questions from the chat. So if you guys wouldn't mind, because of the short time, to write your questions in the chat, we will answer them and speak to them. Chris, do you have anything you'd like to add?
Well, I think we actually made use of the time, right? So even though we had some issues with the sound. And I noticed that throughout, that it was just scrolling through the chat, and I see there's some questions have been already answered. So I'm not so sure if I'm going through the chat right now. Embedded BW on SE4 HANA. Okay, so this seems to be, Dinesh is asking, some clients are using embedded BW on S4 HANA, and there are cases where clients are using BW for HANA as a separate box. What would be the best approach? I don't know, Joe, if you also can join the answer for me. It depends on, it's a case by case. You may, the embedded S4 HANA, it's operational reports. They are not, they help removing the operational reports from your BW application back to S4 to be very tied to the data as it gets created. However, if you need some train analysis, if you want to reach the data with external sources, the embedded BW analytics would not be the best approach in my view, especially because being an operational system, the S4 has its data aging is a little bit different than in BW. You may want to keep 7 years worth of data in the BW application in a separate box, and meanwhile you just want to protect your HANA box supporting S4 with a more restricted data life cycle. So, and you may not want to bring external data to your S4 application as well.
Yeah, exactly, Chris. And I would also add, it really is a question about the user concurrency in the data volumes that are going to be reported, and how that impacts memory consumption and CPU utilization on your system. And if you're going to try and pack all these things together in one system, you can say, look, I'm an S4 on HANA. I don't need BW anymore because I'm on HANA. I don't need to stage my, that's true to a certain extent, but the laws of physics still apply here. If you're still doing financial comparison reports year over year, prior year to current year to date, on large volumes of data, and you've got thousands of users running concurrent queries against this data set, you don't want to be doing that on your operational system. That's going to incur a lot of risk that you're going to have out of memory errors, or so forth, not enough CPU to run your operational processes in that system, and you certainly don't want to embark down that road. So you need to make sure that your systems are appropriately sized. And if you're going to embed your reporting into your operational system, then you just need to make sure that you've sized it appropriately to support both.
Okay, scrolling through the chat, seeing any other question that have not yet been answered before the presentation. Will you be forwarding the presentation to us today? I believe so. I think if it's not today, it will be tomorrow. Nicole will be forwarding this slide deck for you guys, I believe. No audible sound. A lot of things about the sound. I can hear, cannot hear, I can hear, not hear. So
there's questions about using a DSO. Why would you even use a DSO? From Bill, DSOs still provide, in my mind, a lot of value, and there's a lot of functionality packed into the advanced DSO. It does a lot of different things and supports a lot of different use cases. Whereas table in HANA, native HANA, is just a table, and yeah, you can build a view on top of that. If you don't want to use BW going forward, and you don't want any of the analytic capabilities that BW provides, sure. We see a lot of clients experimenting with native HANA solutions, but what's interesting is they want all the functionality that BW provides. They just want it in native HANA, and it's just not there yet in native HANA. All the functionality that BW provides. Someday, I'm sure it will be. That there won't be a difference between data warehousing on native HANA and BW for HANA, but that remains to be seen.
Okay, so yeah, go ahead, Joe.
I see a question from Dinesh. Are there any upcoming sessions explaining scenarios and details? What kind of specific scenarios are you looking for? I mean, there is one other session, but it's covering data acquisition and a few other topics. So I don't know if that's going to address your concern or your question, Dinesh. Best thing would be to visit us at TechEd and speak to us in person if you have some scenarios you'd like to discuss. Some of the other mixed use scenarios. Mm-hmm. Again, there's a lot of different options for mixed use scenarios, and I would take that on a case by case basis. I mean, if you're you have to consider what ETL tool you're using to load data in, where's it coming from, and what functionality you need to report on it. I mean, the only reason why you would want to use CDS views and report on BW for HANA is so that you could get that analytic reporting engine that BW has and build BW queries on top of that, right? And there's a lot of robust functionality in the BW Query Designer that is optimized for HANA and gives you the option to build complex structures or things like that for your reporting needs. Those are challenging to do in a native HANA environment. So that's one scenario, but it really is case by case basis. Any other questions? Okay. All right.
All right, guys.
We're
So
5
sorry.
minutes over.
I hope. Yeah. Well, hopefully this was helpful for you guys, and expect you to see you guys over there at TechEd. Please come say hello, and thank you for your patience today with a little bit of the technical issues we had. Thank you, guys. Joe?
All right. Thanks, everyone. I'll see you all at TechEd.